Okay. All right, so homework for today, we're kind of reminding ourselves while we're transitioning to writing objects in Java, building on our knowledge from writing them in C++ last semester. So this is actually something pretty similar to what we wrote last semester with the fraction class, but now we're writing it into Java and hopefully seeing the similarities. So for the assignment, we're supposed to write a class called fraction. That's keeping control, that's managing two variables, a numerator and a denominator. So we're going to have two fields in this class. And then we wanted to give it the ability to display itself. We can tell a fraction to show itself. All right, so let's go ahead and write this. So I'll let's create a new project. Well, I'll probably get questions up there. Somebody let me know if somebody put something in the chat if you happen to be on, or just yell out if you're online. Okay. So I'm going to go ahead. Probably Amazon, that was FedEx delivery. They're throwing nice tight spirals from the end of the loading dock. All right, so we're going to go ahead. We're going to create a new file here. We're going to call this guy fraction.java. So the name of your class, name of your file has to match the name of your class. So the name of your class matches the name of your file, case sensitive and all. So we're going to have a class called fraction with a capital F. So this will be stored inside of a file called fraction.java. All right. So we're going to create a class called fraction. Perfect. All right, so that becomes our top level container. We're going to have two fields in here, so I will make them private fields because we're good programmers and we want to keep our security locked down. And if we were going to give access to one of these variables, if we wanted read-only access, we'll make a getter. If we want to give changeable access, we'll make a setter. But we'll make these guys private. So we're going to have, now if we're storing a numerator and denominator, we're going to go ahead and just decide these are integers. All right, so we'll say private int. Actually, I'm going to go ahead just for where we're going with this. I'm going to go ahead and make it a long, so it'll be able to hold bigger integers, let's say. And we'll call this guy numerator. And we'll say private long denominator. All right, now our constructor for the fraction class has the same name as the class name. So it's going to be fraction. And this guy will take in a long numerator and a long denominator. And then we'll set this dot numerator equal to numerator, this dot denominator equal to denominator. So this will be the guy that allows us to construct a fraction. All right, now we're going to go ahead and have a public void display. So we'll teach our fractions the ability to display themselves. All right, so we decided to display a fraction. We're going to put it on the screen in some sort of visually appealing way. So we'll say system.out.println. And maybe we say this dot numerator followed by a slash, followed by this dot denominator, something like that. And that'll give us our display version of a fraction. All right, so that's it for our fraction class. Go ahead. Yeah, I probably expected most of you to have used int. If you remember back to our primitive types, we have byte, short, int long. So a long is just a integer capable of holding larger values. And I'm doing this because I want to move towards adding these guys up and remind us of that. I think we did it last semester, Euclidean algorithm for greatest common divisor. I like to remind that because adding fractions, well, reducing fractions becomes a complicated type thing. So I'm just giving ourselves the ability to have really big fractions if we just kept adding them together. So that, and then that's just being a choice. I know, so the homework assignment was to create a class called fraction that manages a numerator and a denominator. From the programmer's perspective, we get to decide what kind of data type do we want to use to store the numerator and the denominator. And I'm going to use this as another upgrade to what we saw in C++ last semester, where we'll actually implement this a little bit of a different way, probably for our next assignment. All right, so I chose long so it could hold really big values, but you can do whatever you want. So now back in main, we're going to go ahead and test our fraction class, because at this point, all I've done is I've defined a blueprint. I've defined what it means to be a fraction. Specifically, I've given myself a constructor that allows me to actually create fractions. And then I've given my fraction a single ability. Fractions know how to display themselves. And this is a non-static method. So it's owned by an instance of the class. Therefore, we will need an instance of the fraction class in order to call this display method. So we'll go ahead and create a couple of fractions here. We'll say fraction f1 is equal to a new fraction. And let's pass it 1/2. Fraction f2 is equal to a new fraction, maybe 3/4. Say f1 dot display, f2 dot display. So build two fractions. Tell each one to call their display method. So there's our solution to the homework, or a solution to the homework. All right, questions about anything in the fraction class here? Go ahead. Yeah, so you did this, right? You were like that. Yep, and it'll still work, but let's talk back through why. So we talked about this last class. Why did we not need this dot in here? I'm still going to say you should always put this dot. If you mean the fields, you should say this dot. But why did we not actually need this dot numerator in here and this dot denominator? Why isn't that necessary in this particular case? Go ahead. This is a whole separate part of the program, I guess. But if you wanted me to, let me expand my question a little bit. Why did I not need this dot numerator and this dot denominator here, but I did need this dot numerator and this dot denominator here? The answer is the same. The correct answer to what I'm asking is the same, regardless of which of these two. Why did I need it here, but I didn't actually need it here? Go ahead. Yeah, so variables always resolve to their most local definition. So if I'm looking at this variable right here inside the display, Java is going to say, what is the value of a variable called numerator? And the first thing it's going to do is it's going to look in his own neighborhood and say, is there a variable defined here called numerator? It's not going to find one. So then it's going to say, okay, well, let me jump up to my next most local scope. And that's going to be the scope owned by fraction. So those are the next guys there. It's going to find numerator there, and it'll boil down to the correct value. That's why it did work. without saying this dot. But up here, if I had just said numerator is equal to numerator, variables resolve to their most local definition. So numerator is going to resolve to this guy right here, not the guy I meant to set it to. So this dot is required here. Or what I would say is poor programming practice. A programmer might just say, oh, I'll just name my parameters differently. And then it happens to work, right? For the same reason. All variables resolve to their most local definition. The most local definition of numerator here now is this guy. So I'm setting that numerator equal to the most local definition of n, which is right here. I would say that is bad programming practice because we should always name variables with a name that best describes what they're holding. So if numerator was good enough for my field name, doesn't it kind of mean that it's probably good enough for the parameter coming into my constructor? Since that's what I want the numerator portion of my fraction. So I would say it would be tough to make an argument that these two variables should be named differently. The only reason you might do that is because you're trying to be lazy and not use the this keyword or something like that. Or you're actually, it may not even be a laziness thing. It's just like, hey, it wasn't working for me otherwise, you know, at this level of programming. So in this case, we would say this dot numerator, that is the numerator owned by this instance, that guy up here, is equal to whatever the most local definition of numerator is, which is this guy here. In the display method, we didn't actually need this dot because we did not have local versions of those variables. So it did eventually find the scope, numerator and denominator, in one of the scopes accessible here. But I would still say good programming practice is to still spell out this dot. It is going to be a speed increase because now you're not making it go and hunt for the variable. You're not saying look local first, then jump to the next level scope and so on and so forth. You're just saying, hey, don't even bother looking in the current neighborhood. Just go up to the top level and grab one of my fields. Okay. Plus it has the benefit of with command completion stuff that you'll make less spelling errors and that kind of stuff. All right. That makes sense why we didn't need it. And I'll never take off for that kind of stuff. A correct answer is a correct answer, but I'm a big advocate of at least understanding why you're doing something. Same thing with like opening and closing curly braces. You know, in a for loop, if you only have one statement, you actually don't need more. You don't need the curly braces. I would still argue you should always use them. Less confusing, I think looks a little bit cleaner, and you'll never be wrong. You know, but if you're trying to make that decision, do I need them? Do I not need them? That just gives you one more thing to have to think about as a, you know, inexperienced programmer. All right. So now we have our couple of fractions. I created a couple instances of fractions. We proved that we have our display function. All right. Any other questions on this guy before we keep trucking along? All right. So now I'm going to say system.out.println F1. System.out.println F2. What's the output of those two lines going to be? Go ahead. Yeah, memory address, crazy looking thing, something along those lines, right? It's actually a little bit of a partial lie with Java since it's running in a virtual machine. It's Java's fake memory address for this, and you can kind of tell by that. It's when it outputs it here. See, it says this is the fraction that lives at this memory address. So Java sort of fakes it because the Java virtual machine provides its own fake layer that lives on top of our real memory, but it's a memory addressy thing. Okay. So my question is why does this show a memory address thing? We probably would like for printing out F1 to show the actual fraction 1/2. That would probably be an ideal situation. But we want to answer the question for us today, again, understanding how Java is actually working under the hood, looking at some of the things that Java does for us that at least original C++ did not. C++ has gone through a bunch of renditions, and we've actually had some improvements, and some of these things may exist in C++, but I didn't teach their existence in the last class, so we'll look at it as the difference in here. So I want to go and look at this Println function, first of all. So we're going to go and look at the documentation. So the whole reason why we focused earlier this week and last week on this idea of static versus non-static methods, and really understanding those two, that if a method does not have static in front of it, that means when we define it, that means it's a instance method. We call it using an instance of the class in which the method was defined. If I do see static in front of it, that means it's a class method. I'll call it using the name of the class in which that method was defined. So if I understand those two things, when I look at the documentation, it tells me everything I need to know on how to call something. Okay, so one of the important things for us here is learning how to read documentation, because our job as a developer is not to memorize everything that's built into every language. And it's just not going to happen, right? You're going to have your core stuff you use all the time. You'll accidentally remember that stuff, but we're going to go and look at documentation. So let's try to understand what is going on with this Println thing. So if I just look at this line and I start trying to deconstruct it, what kind of animal is Println? We have, remember, classes have three members, right? We have fields, constructors, methods. So is Println there? Is it a field, a constructor, or a method? And why? We're looking at it being used, not the definition of it. We're looking at it actually being used. So we kind of see this guy out in the wild. We're doing one of those African safari tours, and we see something run by. And we say, "Oh, what animal was that?" So we see this guy. What is he and why? So is that guy a field, a constructor, or a method, and why? Go ahead. Okay, it's a method. How do you know? Okay. Possibly seems like something's calling it, but let's focus just on that part there. Why do you think that guy just there is a method? Because I could even take out this other part. Why is this guy a method? But
I would say because he's not like building it, so he's not really constructing it, and he's not like being given a value like a hold at the field.
Okay, so how do you know it's not a constructor?
Because a constructor, it's like how you make the fraction class, like you're making something with it, like you're giving it input value, like
how do you know you're making something up here? What's always there before you use a constructor? Yeah, new keyword. So whenever you're calling a constructor, you'll always have the new keyword before it. Okay, so we know this guy's not a constructor because we could have narrowed it down right off the bat. We could say, well, he's either a constructor or a method, right? Now we can start saying, well, he's probably not a constructor for a couple of reasons. Well, he starts with a lowercase letter. Now, it's not a rule that classes have to start with an uppercase letter, but most classes happen, a naming convention is that they start with an uppercase letter. So we can be very suspicious that this guy's not a constructor because constructors would match the name of the class, and classes typically start with an uppercase letter. We can then solidify that by saying, oh, I also don't see the new keyword here, so it must not be a constructor. All right, so if it's definitely not a constructor, that means it's either a field or a method. How do we know this guy's not a field? Go ahead. We're seeing it being used here instead of being the definition. So this would be when we look at it and say, here's the definition, definitions. might have data types before that, but when we actually see it running around in the wild, we wouldn't expect the data type out of this guy anyways. So how do we know that that guy is not a field? What do fields never have that we see present here?
Parentheses.
Parameter list, parentheses. They don't have to take any parameters, but every single method will have an opening and closing parentheses. All right. So we see this guy here and we say, okay, this is some kind of method. Now we know that methods come in two flavors. They come in static and non-static flavors. Now, if I'm looking at the method definition over here, all we have to do is look in this area right here to see if it's static or not static. All right. But we're not looking at the definition. We're actually looking at these dudes running around in the wild. Right. So I'll go ahead and put my system out back in here. So if this guy was a static method, a class method, who should be calling it? Go ahead. If it's a static method, class name itself. If this guy happened to be defined as a static method, we would expect that this guy would be called using the name of a class. Now, who is calling this guy? That dude right there. Out. Now, for the same reason I said a few minutes ago, out is likely not the name of a class because it's not capitalized. Okay, so chances are out is probably the instance of a class. It's a variable of a class type. All right, so since I have an instance of a class calling this method, I would expect that if I were to look at this method in the documentation, I would not see static in front of it. It's an instance method and therefore needs to be called using an instance of the class in which it was defined. All right. What kind of animal is that guy? We already know it's an instance something, right? So it's a non-static thing. My choices are field, constructor, method. Well, is it a constructor? How do you know it's not a constructor? No new keyword, not capitalized, all sorts of evidences, right? Not a constructor. Also doesn't have parentheses. Breaks all the constructor rules. All right. So not a constructor. Is it a method? How do we know it's not a method? No parentheses. All right. So it must be a field. Okay. Now, is it a static field or a non-static field? Follows the same rules as methods. If it's a static field, we would call it using the name of the class. If it's a non-static field, we would call it using an instance of the class. Who are we calling this guy with? System. Is that a class name or is that likely a class name or is it likely an instance of the class? Probably the class name. Why? Capital letter. All right. So if we were just to break this down, just we saw it running around on our tour, right? We're trying to say, oh, what kind of animal was that? We would say, okay, well, this is an instance method being called by this instance, who is a field being called by this class name. So this guy must be a static field and an instance method. And this is the name of a class. That makes sense? All right. So let's now go and see if we're right. So we just looked at it in the wild. So now we're going to go over to our Google search and, say, okay, I saw a cat running around. It had spots and, you're trying to figure out what kind of animal was this actually, right? Last night I was coming home from dinner and I saw it was it was either a humongous raccoon that was very, very dark furred or it was a bear. And this was in Mecwood. And I don't have full confidence that it wasn't a bear. It may have been a bear. What am I doing? Okay. So we know that there's going to be a class. Let's say Java system class. This will just get us to the documentation real quick. So here is a class called system. That's in the Java documentation. All right, so now if I'm going back here, I expect to find a field inside of the system class that is a static field, because I'm seeing it here in the wild being called by the class name. So I expect to see a field in there called out that is a static field. Make sense? That's what I'm expecting. Let's go see if we're right. Here's our field summary. Here's a field called out, and it is a static field. So out is an instance of, in this case, the Println class. The documentation tells us what kind of thing out is. Out is an instance of Println. Okay. Going back here, so I went to the system class. I found his field called out. That was a static field. So far our guesses are pretty accurate. So now I'm going to go to that class that out is an instance of, which is the Println class. And I expect to find a method in there that does not have static in front of it. Because the way I saw that method being called is with an instance of the Println class, not the Println class itself. So I expect inside Println, I'm going to find a method called Println. So here's Println. We'll scroll down. Here's a method called Println. Here's another method called Println. Here's another method called Println. Yada, 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 yada. Whole bunch of methods called Println. All right. Starting point. Polymorphism. Fancy word that means having more than one method with the same name, but a different number and or type of parameter. The parameter name does not matter. If you had two methods called Println and one took an int A and the other one took an int B, to Java, those are the same method. Doesn't matter if the parameter names were different. Those are two methods named the same thing that both take a single int. And Java's going to scream at you, saying you can't do that. But it will be common, like we're seeing here in Println, for there to be more than one method with the same name, because what's the purpose of a method? A method gives an ability to a class, right? We wrote a class today called fraction. And so far, we've given this guy a single ability. We gave him the display ability, right? We taught him how to build himself so he could bring one into existence. And then we also gave him a single ability called display. All right. So methods are abilities that a class provides, either through an instance of the class or through the class name itself, depending on what we're accomplishing. So the Println class here has Println defined a bunch of times. An example of polymorphism here, where each one takes in a different number and or type of parameters. This guy takes in 0 inputs and he just kicks it down a line. This guy knows how to print a Boolean, print a char array, a double, a float, an int, a long, a string, and then an object. Okay. So that means that there are a whole bunch of different Printlns that exist. If I go into my fraction class here, which Println is actually getting called right here? What kind of value does that boil down to? A string. Okay. I'm building a string, so I'm taking my numerator, I'm concatenating onto that, the string front slash, I'm concatenating onto that, my denominator, so I am building the result of this will be a string data type. That's the kind of animal it is, right? And I'm going to go into the documentation here, and I'm going to notice that there is a version of Println that takes in a string. Make sense? Here in main, which version of Println am I calling here? What kind of animal is this guy? He's an object, but let's kind of, that's the correct final answer. But we'll say he's an instance of the fraction class, and a fraction is an object. When we built fraction here, Java did it for us, but this guy was said to extends object. So we built the fraction class on top of whatever Java said is a generic object. So that means we're going to be, since we're passing an object to Println, we look at the documentation here and we say, oh, yeah, there is a different version of Println that takes an object. So Java is going to figure out which one of these Printlns to call depending on the kind of value we hand it. Make sense? All right, so we're seeing two of them being used here in the wild. One that is a string, version of Println that takes a string. Another one that takes a object. If I say system.out.println 5, now we see the one that takes in an int, so on and so forth, okay? And Java will figure out which one you meant by the parameters you give it. So polymorphism says functions with the same name, but a different number and or type of parameter. So let's go investigate objects for a second. We can do this with any old class. We happen to write a fraction class, but every single class that exists in the Java language will have, at some level in their lineage, the object class. So if you scroll all the way to the top here, we see that a print stream is actually a filter output stream, which is actually an output stream, which is actually an object. So in this case is great-great-great-grandparent is object. So I'll go ahead and click on object. Now object is, we can think of it as like the primitive object type in Java. Object automatically exists in every single object-oriented programming language. Maybe it's a lowercase o, maybe it uses a different name. In the language theory class 470, when we write a programming language, when we talk about object-oriented languages, we say this guy has to exist because every object is built on top of this generic starting point. So in Java, these are all the things an object knows how to do. So we have a constructor that takes in no parameters to say, poof, you're an object. Then we have a set of abilities, set of methods that objects have. So one is clone. So an object can make a clone of itself, which then just gives you new memory. We can determine if one object is equal to another object. It's going to pair pointers, yada, yada, yada. A whole bunch of things here, most of which we will never use, or you'll probably not use in this class. But one is the one we're going to introduce today. All right. This toString method here. This guy returns a string representation of the object. F1 is an object. What the Println method does is if you pass it an object, what it does is it calls the toString method on that object. You see, we get the same output. That's what that object's toString method returns. So this Println method this guy right here, the Println is the one we're dealing with here. this Println method, what he does, if you give him an object, is he will just call, in this case, x dot toString, which boils down to a string. How do we know that all objects will have a method called toString? Because all objects, regardless of their type, in our case here, fraction, we look at fraction here. We wrote this guy. We look in here and say, well, do I have a method called toString in here? Yes, I didn't write it, but because my fraction is built on top of a generic object type in Java, if I go and look at objects, we see that every single object that ever exists in Java will have a toString method. It's guaranteed to have it. The default toString method, as we're seeing, gives the weird looking memory address thingy. That's what it boils down to. Okay, that's what he does. He returns a string, return types a string, takes no parameters, and he just gives some representation of what this object thinks it should look like based as a string. Make sense? So if I'm in fraction, I could decide to write my own toString method, my own more local toString method. Just like variables resolve to their most local definition, methods will also resolve to their most local definition. This is a non-static method, so we'll call it with an instance of the class. So if I say f1.toString, now I'm calling f1's toString method directly. Or if I just say f2, I've already mentioned that if you call the object version of Println, the one that takes an object as a parameter, it's just going to call that object's toString method. But in this case, it's going to find toString more quickly than it did before. Because it's going to go into the fraction class, it's going to say, do you have a method called toString? We do. So it's going to call that one and not bounce up to the objects version of this. So if we run this guy now, we're not going to get that memory address looking thing. Instead, we're going to get the output of our new updated version of toString because we actually run into that guy first, and we're going to get our fractions. So there's our fractions. So the Println method that takes an object as a parameter, its magic is it will always call that object's toString method because all objects are guaranteed to have a toString method because that's how objects were written in Java. But if I choose to give it a more local version of toString, I said, oh, I'll go ahead and give it a toString before it gets to the other guy. It'll get to this one and return that answer. Now, what if I also want the memory address thingy? I can go ahead and say return super.toString, maybe concatenated with a dash and a dash like that. Super is how an object refers to itself. Well, super is how an object refers to its parent within itself. So from fractions perspective, super is the instance of object. And objects toString gives us the memory addressy thing. So this will boil down to the memory addressy thing as a string. I'll concatenate onto that a dash. I'll concatenate onto that my fraction, pretty fraction looking thing. So now I'll get kind of a both and situation where we get the memory address, the result of super.toString, and we'll get our other thing. So now we're proving kind of that lineage. Does that make some sense? Now, you don't have to write your own toString method if you don't want to. It's not a requirement. But if you are creating an object and you think that, hey, it might make sense for people to want to print out this object, for instance, it might make sense for people to want to print out a fraction, we will go ahead and we will give the ability for this fraction to be able to be used with the Println function, be compatible with it. And to make it compatible with it, we just write a toString method in there that'll spit out this guy's compatibility. Okay, so keeping our practice up. Homework for Monday. Here's our starting point for it. Add the ability to add another fraction to a fraction and return a brand new fraction. That is the result of the addition. So this should look like fraction add fraction other. So inside the fraction class, we are going to create a method called add. It's going to return a fraction and it will take another fraction as a parameter. You did this last year in C++. Do it again here in Java. You don't have to return it in reduced form if you don't want to, but if you want to challenge yourself, you can go ahead and do that. Questions, comments, concerns, bribes? All right, I will see everybody on Monday. Take care.